One of the main issues probably that is not well discussed before, and we see that the hydropower or hydroelectric plants are considered as renewable, but it doesn't really mean that they are zero emissions in terms of carbon emissions or carbon emissions equivalent. So if you look at the carbon emissions accounting for hydropower, we see that the construction time will entail a lot of time because it's a very big project. And so when we look at, for example, this is example of Three Gorges Dam in China, and we look at the how vast is the part where the water is being contained. So it means that this part here is actually the part where there's a community before. All right, so there you have to displace a lot of communities and a lot of possibly forestry, some animals there because you need to impound a lot of water volume. And so in doing so, if we look at the natural way of life, for example, the trees, the plants, the animals, they usually already release carbon dioxide on their own. But because of this activity here of displacing these things and putting some water, and so these plants and animals, aside from releasing their own carbon dioxide, they will now be degraded. You know, once they are submerged in water, they die, and then they degrade into below the bottom of that dam. So, for example, here. So now these dead plants and dead animals, the organic matters, because of the absence of oxygen at this bottom here, so there will be what we call as anaerobic degradation. So this anaerobic, with the absence of oxygen, is now producing methane and carbon dioxide. So the methagenesis process produces this methane and carbon dioxide. As you remember, methane is a very potent greenhouse gas. As you remember this one, methane is even much potent compared to carbon dioxide alone. So the global warming potential of methane is many times higher than carbon dioxide. So once it is released through in air, then it will definitely contribute to the climate change problem. So because of the flowing water, because of the dissolution of this CH4 and CO2 in the water, and so it goes towards the turbine, for example, and then it flows, and then there are some mixing there. So they degas. So they go out from the water and they join on the atmosphere. So now it contributes to the global warming. Aside from that, there are a lot of other plants and animals that also degrade. And so they have some aerobic oxidation, for example, releasing some CO2, some sediments also falling here underneath the ground, and even the soil erosion. For example, during the putting the impounding of a lot of water in the dam, so some soils are eroded. It means that they are, they break, for example. So as we know, CO2 are deposited underneath the ground for it also. And once some soil erosion will happen, so it opens up some pores which releases this carbon dioxide and even some CH4 that were already there because of for a long time they are there. Because of the soil erosion, some cracks will happen and then they will also be released and bubbles out of the water surface. And so they join as greenhouse gas. All right. So these aspects will basically is one of the main issues for the hydroelectric power plants. These production of such CH4 and CO2 as well. Now, aside from that, if you look at the magnitude of these hydropower plants, hydroelectric power plants, you see that you use a lot of concrete here. And so during the construction, concrete is also a source of CO2 emission, right? So you are spending material and money for this one as well. So this will be a source of CO2 emissions. And so if we try to see how much of that carbon is actually emitted when in comparison to some for example, coal-fired power plants with these efficiencies here, you can see that the life cycle assessment could, the hydroelectric power plant, as I mentioned in earlier examples in other videos, is around about 4 to 12 kilograms of CO2 per megawatt hour of electricity produced. So this is for the life cycle. And for coal is around 955. So in consideration, as long as we can control the release of methane from these organic matters here, we can still see that hydropower plants are much less, carbon emissions compared to coal. But then again, that is saying that we managed to control the various effects of CH4 production from these dams here in these dams, this side here. So management is important so that we can minimize the release of various greenhouse gases from dams. So let's try to discuss now some of the other environmental impacts of the hydroelectric power plants, its positive part and also the negative impacts of these plants. So we have a table here showing the both positive and negative sides of hydropower. So in consideration, during operation, maintenance and everything, we can still say that hydropower based on a natural cycle is still emissions free during the operation. As long as we can manage, particularly manage the release of methane and some carbon dioxide during the operation. It is a very good renewable energy source with a very high energy efficiency and capacity factor for most of the hydropower plants around 30 to 60%. So it really depends on the situation of the rain, for example, the source of water, and the operation, the demand. So there are a lot of things that will be considered for capacity factor. But in terms of efficiency, it's quite high, even up to 90%. It is a form of dispatchable energy with storage capability. As I mentioned, the pump hydro can act as a battery to store the energy. And so the dispatchable means that whenever there's a demand, we can easily control by the operator how much energy is released or generated depending on the demand. It can be used for base load, peak, and pump storage applications as mentioned. It could also be scaled into various capacity, coming from small head or low head to high head systems. So for run-of-river systems, for example, we can generate 10 kilowatts of electricity to about 10,000 or 10 gigawatts of electricity. During operations, it's quite low maintenance cost. And in terms of lifetime, in comparison to other energy sources, is quite long. It's about 50 years, more or less, for a lifetime. So it means that we can generate as much energy for a very long time, even half a century for that. For example, in Australia, we have a number of hydropower plants that we are nearing 40 years old already. And so, yeah, we've been generating a lot of electricity coming from our hydroelectric power plants. Of course, environmental impact, as you mentioned, some negative parts of the hydropower. There is the need for a low use amount of water. And so when we say use amount of water, so there's a large area that is needed. And so rain is very important for this matter because this is the main source of where the water is coming from. And so also when we impound a large amount of area, it means that we need a large land area to hold that water. And so we have to clear out whatever is there in that land. So the habitat of some of the animals, the plants will be affected. And so there's deforestation. So when you say deforestation, we are losing some of the carbon sinks, because forests and leaves of the trees will actually absorb CO2 supposedly. And so when we try to cut off these trees, then we are losing these carbon storage facilities, for example. And so the output of the hydropower plants also are variable, so it depends mainly on the rainfall and snowfall. So this is the natural cycle. There is also the issue of the impact on river flows, because once you build a dam, so you actually basically putting a stop on the river system and just to impound the water. And if we are using a run of the river systems as well, it depends on the design, but they could affect some fish because of the presence of turbines. Some oxygen could be depleted as well because of the presence of organic matters that utilize a lot of dissolved oxygen in the water. Of course, this is a very big issue, the social impacts. For example, even for indigenous people could be a problem as well if we are putting some the land that are being used by people. So there will be some stratification experience for a number of people, not only indigenous people, but of course people in that community where the hydropower plant will be constructed. There will be some issues of health. Some people may have a lot of stress because of this construction. Some stagnant water in the dam area will contribute to the malaria problems, some mosquito problems, for example, and that could impact the health communities as well. In terms of economic situation, when we look at dams, there's a really huge capital cost for that, and it will also entail very long time construction. And so this will be a big problem in terms of the money. Yeah, so we have to consider that one. This is not a small scale project in usually unusual case. And of course, I mentioned that there's a very long time for construction of mega sized projects, which could be quite stressful for a number of reasons for different communities. And one of the major that maybe not too high frequency, but still can happen is the potential for dam failure. And so this is something that we need to really avoid, because dam failure will lead to a lot of flooding, and that will be a devastation, a very big devastation, and that should be avoided as much as possible. So an example of which is what we are seeing here. Once, because we have a huge amount of water, body of water in the dam, then this problem of poorly constructed dams and concrete structures and damaging this one will lead to floods and death and community destruction surrounding the area. And so it's rare. It's not happening as many times, but it could happen. And this is some parts of the what happened in previous years. So overall, what we can see from here is that there are some good sides and bad sides in terms of any energy technologies anyway. But for hydropower, there could be a lot of devastation if not properly designed. But then again, there's also a lot of potential of really generating a good amount of electricity based on the energy from water, from the moving water. And so the overall, as